So, hello and welcome to our webinar about nested multi-model tracking. I'm Benjamin. I'm the lead developer for the VisionLib SDK at Bisometry. A brief note in advance, I think some of you already asked. We will record this webinar, and this way you will be able to watch it again afterwards. At the end of the presentation, there will be time for questions. And if at any point during the presentation you have questions, you can either post it in the Q&A section in this meeting, then we will try to answer them during the meeting, or you can note them for the end of the webinar and ask them at that point in time. We as Bisometry, we are a team of about 30 enthusiasts and experts in different fields related to augmented reality. And at the moment, we have two main areas in which we are active. On the one hand, there is VisionLib, our object tracking library, which most of you probably know. And on the other hand, we developed Twin, an AR-based quality inspection tool. In this webinar, we will focus on VisionLib, more precisely on a new feature of VisionLib, nested multi-model tracking. So we will start with an introduction about the term nested multi-model tracking and differentiate it from the general multi-model tracking approach. Based on that, we will introduce two use cases which are enabled by nested tracking and can be implemented very simple with the new VisionLib 3.1. Some additional notes: nested multi-model tracking isn't limited to Unity only. It is also possible to use nested multi-model tracking with our C interface. A good way to do this is to define the tracking anchors in the tracking configuration file, and we also added some examples for doing this in our documentation. In this webinar, we will focus more on the Unity side of this feature, because this way we can describe it more vividly. The general multi-model tracking in VisionLib allows the user to track several models in parallel. Every model can move independent from all other models, for example, tracking several cars driving on a road. Every car may have its own velocity and its own direction. Some may pass others and integrate back into the flow. In contrast, nested multi-model tracking is based on a close relationship